And we are also live on Zoom. So we have 3 channels today. So please say hi, where you're from. And then for those of you who are new, these sessions are live and occur every 2 weeks on Thursdays at 9 a.m. Pacific time. So we bring a panel of contributors and champions of Delta Lake to answer some of your questions about Delta Lake open source software, and also the things we are doing with other open source ecosystem projects. So welcome all of you. We will get started shortly. All right. So without further ado, let's go ahead and get started with introductions. So Fabian, do you want to kick it off?
Sure. Hi, everyone. So I'm Fabian. I'm currently an active committer and contributor to the Apache Flink project, and I'm currently employed with Ververica. And yeah, I'm basically here today to talk about the new Flink Delta Sync, where you can just write your data from a Flink pipeline into your Delta Lake.
Awesome. Thank you, Fabian. Scott, you're up next.
Hi, everyone. I'm Scott. I'm a software engineer on the Delta ecosystem team here at Databricks. And I'm here today to talk about a bunch of things, including Delta Lake 1.2.1 and .0, our huge new release, which includes a lot of features that I worked on and that our team worked on, including data skipping and adding multi-cluster writes to S3, as well as our connector ecosystem, which includes the Flink sync that Fabian's here to talk about as well.
Awesome, awesome. Denny.
Hi, everybody. My name is Denny Lee. I'm a developer advocate here at Databricks, a longtime Delta guy, just here to help out. So make it that simple.
That's awesome. I'm excited for this panel. So a mini recap from last session, we had TD and Ivana who provided amazing insights on the key features of Delta 1.2, which included column stat generation and data skipping, which is a big boost to read performance. We had also discussed file compaction feature and improvements to restore to Delta table to earlier snapshots. We also chatted about the Delta connectors with other open source tools like Delta Flink Sync and updates on Delta Flink source. And also we got a few insights on future releases like Z ordering and some of the other features which we can still hear from our panelists today. In case you missed it, the recording is still available. I'll share that in the chat. So this brings us to today's session, where I'm excited to talk about other things Delta, like data processing, streaming, and the Flink Sync connector with Fabian from Ververica, the original creators of Apache Flink itself. So, and then we have other contributions from Scott, Denny, and other Delta Lake contributors. So we will discuss that. Without further ado, let's go ahead and take some questions. So let's talk about Flink Sync connector. So Fabian, can you give some highlights on what this connector does? What are current capabilities? Yeah.
Mm-hmm. Yeah, maybe let me start with a quick few words about Apache Flink. So Apache Flink is like very similar to what probably most of you have already seen or heard from Spark. So it's like a unified batch and streaming engine. But like in the recent days, we are mostly focusing on our streaming execution, because we see like batch mainly as like the special case of streaming application. So the new connector can be basically be used in like streaming and batch use cases, but we are mostly primarily focusing on like streaming use cases, where you can insert your data into the data lake with low latencies and high throughput. So the idea is, currently we are still working on different API levels of the Delta Sync, but in the current situation, you can use it right away. I think it has been released with one of the Delta releases, so probably Scott knows more which Delta release exactly it came with. So yeah, I'm looking forward to your feedback using the project.
Awesome. Denny and Scott, from your standpoint, what are the how did the release go? What were the features or things which got you excited throughout working on this project?
Yeah, for sure. So just to answer Fabian's question there, yes, it was released with the Delta Connector 0.4. Delta Connectors is a separate repository from the main Delta core, which contains all of our Spark list connectors. Because Delta is an open table format, we want it to work with every compute engine. So the Delta Connectors repo contains both the standalone writer, which is our Spark list writer and reader for all the Delta log metadata, as well as all of our future connectors, which includes right now the Flink sync, which was just released. And then in the next release in the coming months, we also hope to release the Flink source. So a lot of exciting work going on there.
That's awesome. Denny, would you like to add anything?
I mean, really, I think Fabian and Scott covered most of the callouts. But if you are interested in testing, if you're interested in also participating and doing some more additional PRs, please join us in the Delta user Slack. I'm probably going to be a broken record on this one, but join us here. There's actually a Flink connector channel specifically to talk about these things as well. And so we'd love to get your feedback. This has been a very popular project. Lots of folks have been asking us tons of questions about this from the community in general. So please, love to have you test it. That's pretty much my little addition.
Awesome. So with that note, Denny, there are some questions around like what are the limitations of this connector? So, Fabian,
I can start. I think one of the current limitations of the connector is that in the first version we only support like amending to tables. So basically, we can create the table and then amend to existing ones. But in the future, we will also like plan to support like upsert statements where we can basically update existing tables. But this is currently like not supported yet.
Got it. And are there any others? And if this is the limitation, what is the plan of making it, available in the next release or something? Like, can you give us some insight?
Yes. So I think the next few releases will mainly concentrate on like bringing the Delta sync to like the other APIs that are supported in Flink. So one very interesting project that is currently being worked on is like bringing it to SQL, so that like it makes it like way easier for businesses to try the Delta Connect if you can just use your usual Flink SQL statements and you do not have to like worry about any internal or any of the connector APIs. And one thing that also like becomes like more and more important in modern businesses is the use of catalogs, that you can basically share the different Delta tables within your organization or within the different teams. So I think this feature will also be live once the support for Flink SQL is released.
Got it. So I think you touched on a lot of the uses and limitations. There is also a question on what are the pros and cons of using Flink over Spark?
I can start, and then probably someone from Scott or Lee can take this over. I would say there's no like clear winner in terms of if you're thinking about performance or any of these kind of like metrics. I think it really depends on a bit of if you're working in like a larger organization, what kind of expertise is already in your company, and then it depends on if there are like more people already familiar with Spark or more people already familiar with Flink. And I would probably say that the current Delta Lake support is still better with Spark, so this is probably where it originated.
Got it. Scott or Denny, would you like to add anything else?
Yeah, I mean, I'll just add it a little bit. I mean, exactly as what Fabian would call out, right? I mean, if you're already familiar with the Flink ecosystem, that makes a ton of sense. If you're already familiar with the Spark ecosystem, that makes a ton of sense. Each has their own strengths. We're not going to do a competition here, right? What we're really talking about is the fact that both systems do require, though, reliability on the underlying storage, right? And the fact is, your Cloud Object Store can itself, whether it doesn't matter which distributed system you're working with, will ultimately have issues when it comes to orphaned files. That really a transaction log is going to be super helpful to ensure you have the reliability of your data. So that's what we're really focusing on today. And just like Fabian called out, there are some aspects that because Delta Lake was initially built with Spark, that we have a little bit more code base available for that, admittedly enough. But as you can tell, Flink is super important, super popular. So we've started already with the data stream API for starters, which is around Flink 1.12. Then we're currently working on the table API. That's what Scott had already called out. That's Flink 1.14 onwards. Correct me if I'm wrong with the version numbers again, by the way. So I'm trying to do this all out of memory. And also this allows us, and also we're trying to work on the Flink Delta source. So we're getting these features in. And that's actually what I meant by going ahead and pinging us on the Delta user Slack, or especially the Flink connector, because if there are other features that you would like to see faster, and especially if you're interested in pulling pull requests of your own, please do chime in, because we'd love to go ahead and, number one, get the help. And number two, also get your opinion and feedback on what's working and what should be prioritized.
Awesome. There is a question around, so since you mentioned about catalogs, there's a question around, do we have more in-depth Kedro catalogs for Delta tables? Kedro catalogs.
Kedro catalogs?
Maybe, I don't think I know about
I think are you buying, to the person who asked the question, are you by any chance referring to Kedro, like the McKinsey project, open source project? So if it's that, so Kedro actually works more like is sort of like a project that actually works on the ML flow side. So it's not to say that it can't work with Delta Lake. Quite the opposite, it can actually, but I'm not entirely sure what the question is. So I apologize. Okay. If you can clarify that a little bit, I can probably help explain that one. But yes, just a long story short, Kedro actually we actually have a partnership, well, a community that's working together with Kedro and MLflow and Delta Lake, but it's still very early stages. So I didn't want to like promise something yet, because again, very early stages. So.
Yeah, I think that helped, Denny, and you hit the right product, Kedro, which works with MLflow. So I think Dipesh is nodding that, this is what I'm asking for. Awesome. There's another question on when we should use Delta Lake, when we can store data in ADLS Gen 2. What should be trade-off? For example, if I created a Delta table, can it be shared among other teams with different access levels?
I can tackle that, and if others want to chime in afterwards. So in general, ADLS Gen 2 is a format that works perfectly great with Delta Lake. So you can absolutely, whether you're working within the context of, for example, something like Azure Databricks, or you're working within the context of Delta OSS, where you're generating your own VMs within the Azure environment to save directly the ADLS Gen 2, it actually still is the same process. Now, ADLS Gen 2, as opposed to like S3, and this is also similar for GCS, they actually have this concept of put if absent consistency that S3 does not have. So it does actually have that full transactional consistency issues, which allows us to have multi-cluster writes, multi-cluster JVM, multi-cluster driver writes to the same storage system. In fact, Scott, you can probably chime in afterwards to talk about the S3 multi-cluster write thing, by the way. But to answer your question about ADLS Gen 2, but irrelevant of, even though it does have those consistencies, the thing is that there's still the issue of, and again, whether it's Flink or Spark or any other distributed system that's doing the writes, you could still leave orphan files that a transaction log will protect that data. So because of that, I mean, I would generally almost run always my stuff on with ADLS as a Delta Lake table on ADLS Gen 2 to protect the data. So a bit long-winded, I realize, but the context is, even with the put if absent consistency that ADLS Gen 2 has, I would absolutely still use Delta Lake to ensure the reliability of the underlying data.
Thank you, Scott. I shared that document. Would you like to add anything else?
Yeah, I would just add on some more pros of using Delta Lake in general, of course, whether it's on ADLS Gen 2 or any other cloud storage. It's not just reliability, as Denny said. There's also features, time travel, schema evolution, schema enforcement. There's all these great things that can help you protect your data and query it more efficiently. So yeah, if they would like to talk about this more thoroughly, they should definitely join the Delta user Slack channel, and we can talk a little bit more about maybe what their use cases are, if they're having any sort of hesitancy. But Delta's here to make your data more reliable, more scalable, and more accessible. So definitely recommend. The shirt might be a little biased, but
That's awesome, Scott. So I think that brings us to the next question. So Dhruv is asking, in the last few sessions, Optimize for Delta Lake is going to be made open source in Q1. Any updates on the roadmap? That's perfect because we already released it. And Scott, do you want to tackle that question, like what Optimize does and a little bit expansion on that feature? Yeah.
Yeah, for sure. So Optimize was released in Delta Lake 1.2. And what Optimize does is it helps you compact your files. And what this does is it helps you solve the small file problem, which is that you have these streaming writes, you have all these files coming in, which is great. Delta Lake's able to handle that. We partition our data, but compacting them into larger files helps with reads, helps with the listing problem on various cloud stores. I'm sure Denny can add on more benefits of this feature.
Great. Denny, do you want to add more?
No, actually, I think Scott said it succinctly. I mean, the reality is that it's the blog for Delta 1.2 is coming out. We're going to have a lot more explanations, deep dive into it. So if you want to wait till our next community A&A, we can dive even deeper as well. But the context is it's a great feature that allows for faster performance. And just like Scott called out, if you have any more questions in the interim, either ping us here right now or in the Delta user Slack.
Awesome. So Denny, questions are flooding in. I'll ask another question. Moving from a traditional RDBMS data warehouse to a lake house with Delta Lake, data modeling changes should we make, if any? And so I think he's asking should we make any data modeling changes, if any, and what are some considerations we should take into account when doing this migration?
Oh, no, that's a wonderful question. And so to Zachary, I think you're the one who asked the question live. So again, I'll provide the context. And so by the way, part of the reason why I love it, Zachary, is because I actually am formerly from SQL Server team. So used to build data warehouses. So completely grok where you're coming from. So the question really is about, if I'm coming from a traditional relational data warehouse, hey, I'm going to go move to a lake house in Delta Lake. That's awesome. What considerations do I have to consider? Okay. So from a data modeling perspective, for example, typically we talked about in like OLAP dimensional models, or we talk about in third normal form or things of that nature. In general, that's not necessary. Doesn't mean you can't do it, by the way. I want to be very clear about this. It's not like you can't build a star schema within the context of a data lakehouse. It's just it's no longer necessary to do this. That's the key call out here. Okay, so if you're building the systems from scratch, you don't necessarily have to start with that OLAP schema or star schema. By the same token, if you are going ahead and taking the existing system, in fact, actually, I would transition almost exactly as you would have designed it in a relational data warehouse first, purely from the standpoint to make it easier for that transition to happen. But then over time, you'll recognize there's various advantages, especially when you're working with Spark or Flink or any of these other systems that are interacting with Delta Lake. For example, just things like, do I need the equivalent of identity columns or like UUIDs? Do I need to build surrogate keys? Some of them will be necessary. And in fact, what you'll hear is that we actually have multiple sessions about how to take data warehousing concepts with myself and Douglas Moore on how to do exactly that: surrogate keys, type 2 slowly changing dimensions, things of that nature. So I'll find some time to prop it inside the LinkedIn and Zoom without those links. But again, these common processes that you traditionally do with RDBMSs, you can actually replicate them and advance them within the context of a lakehouse. So with Delta Lake, hopefully that answers your question.
Awesome. Thank you, Denny. There's another question on how we're making integrations with Power BI simple so that it can be used over Delta Lake. We do have integration, so does anyone want to talk about it? Yeah.
That's a great question. So we do already have a Power BI connector. on the Delta connectors repository. And feel free to check that out. That was actually contributed by an external contributor. So the author of that would know more about it than I would. But if you have any questions about that, again, join us on the Slack. Feel free to ask about the specific connector, and I'm sure we can help get you some more information about that.
Yeah, that's awesome. And also we release like a lot of other integrations with other open source ecosystem, as well as reporting tools, data processing tools. So definitely check out our website where we have all this information, and also engage with us on Slack or GitHub so that we can see what you are considering to build, and we will be happy to follow up. Great. So there is another question on so you mentioned about bringing more performance into Delta Lake, and you also mentioned about transaction log. What are some of the features that were released in 1.2 which people can find it beneficial for processing the data?
Yeah, great question. So we've already mentioned optimize. We've already talked a little bit about that, and that will give you huge performance improvements as well. But so will data skipping. Data skipping or file stats collection are pretty much the same solution. So this major feature we added lets you actually collect per column stats as you're writing to the Delta log, and with a very minimal write overhead. And what this means is, in addition to partition skipping during reads, we can actually look at the per column stats to determine which data files to actually skip. And this, various benchmarks have concluded different things about the actual read improvement, but it's pretty substantial. So we're happy about that.
That's great. And then there are some questions about how can we join the Slack channel? I pasted a link in the chat for Slack and Git. Please check that out. I think this remains a very popular question for all our AMAs. Any support for Python connectors? Most existing connectors are JVM based.
I can probably chime in a little bit on this one. So long story short, actually, there is a Python binding that's part of the Delta Rust API. So you can actually check that out. The Delta Rust API actually has Python bindings that allow for read. There's currently work being done for the Delta Rust API for writers as well. And so then subsequently, we'd love to have help to advance those Python bindings to go ahead and support the writing as well. There's also Ruby support in addition to, of course, Rust itself. There's also work being done by the community for Golang as well, by the way, just as an FYI. It's still very much early stage, but so in other words, we can't put it up on the website yet, but there is actually work being done on that front as well. So just as an FYI.
Awesome. There's a question about migrator to, yes.
I would actually love to add one more thing to Denny's answer there. Yeah. So one thing I would love is help on getting more Python bindings. So for example, we have the JVM based Delta standalone library in the Delta connectors repository. And what we want this library to be, and what it is right now, is the source of all metadata interactions with the Delta log not involving Spark. This is our Sparkless standalone library. And currently it's JVM based, but we would love an open source community member to go and help us or make a project plan or make a design doc to add Python bindings to that. Because again, this is the source of all metadata interactions. We'll be adding more features to it over time for our Sparkless connector, and adding Python bindings to that would be able to have a lot larger scope of impact, since our Hive, Flink, etc. connectors are already using this as well.
That's awesome call out. I think, yeah, so thank you, Mayank and Andy, for asking great questions. There's another question from Dhruv. He's asking, when is the Rust API for writing scheduled for release?
Oh, right now it's currently planned for Q2, which is basically the way I figure around June, July, roughly. We have regular updates actually on it. So just join back to the Delta user Slack. There's a Rust API there's actually a Delta Rust channel as well. So you can definitely ping your questions there. But right now, at least, that's where we're currently at. Great.
There's a question about star schema design. So the question is, based on Denny's reply on on-premise data warehouse skills, in short, what is the best practice in modeling data in Delta Lake if we forgot about if we forget about star schema design? Are we still using star schema design?
Okay, so it's always it depends. Okay, so now part of the reason I'm using the it depends is because for some people, some designs, what they have done is that they put the dimension data, they've left that in their relational store, right? And so what they're doing is they're running their queries that join the relational data with their lakehouse, with their fact data, which is sitting in Delta Lake. That's a perfectly valid system and especially common when you do a lot of ad hoc queries. So this is a complete normal system, especially when they're using some other system to ensure the dimensional data integrity, okay? Which is, in other words, as you have something like type 2 slowly changing dimensions, you over time will need to update that. This is actually controlled by a third-party system, not necessarily controlled by the same folks who run the data platform where Delta Lake is residing. On the other hand, if you do have full control of the system, it is also just as common to say, forget it, I actually don't need a slowly changing dimension, type 2 dimension, because I'm actually just storing the actual dimensional value directly in the Parquet files that make up the Delta Lake table. That's actually a very valid approach too. The concern usually is when you're looking at like your favorite BI tool, like Power BI or Looker or Tableau, that then the generation of the actual dimension data becomes complicated. So then again, all of a sudden you are inclined to build a star schema. So that star schema may be built after the fact, i.e. when I talk about the medallion architecture, you're building it as post-gold tables versus actually building them with it. Now, suffice it to say, I gave you an answer, but it isn't a straightforward one, is it? And that's more or less the point. It really depends on your environment and how your pipelines are structured, in which whether it makes sense to actually stay with a star schema or to go ahead and remove it. And so, like I said before, I would, if you already have it, I wouldn't necessarily throw it away right away. Okay, I would definitely allow yourself to migrate slowly off it. There, like I said before, there are distinct advantages of having a star schema, and there are distinct advantages of not having one. And incidentally, all the advantages and disadvantages of a star schema, pretty much everyone that you can think about within a database, like for example, the replication of data and things of that nature, actually apply to the lakehouse. So frankly, you probably already know the answer, which is pretty sweet. Hopefully that answers that question.
That's awesome. I think that that gave a very good overview and answered a bunch of questions, Denny. Thank you. So with that, just last question to all three of you. Like, if you all can take a moment and tell us about what is coming up next. What are the features that you are excited about and working on? So Fabian, I'll start with you.
I think I'm really excited about like seeing the Delta source in place, because this basically enables like a nice end-to-end experience. You can basically use your Flink pipeline to process like any data tables you already have and write into other data tables. I think this really enables like using Flink in like a full, fully in full processing mode for like data tables. Wow, sorry.
So end-to-end streaming dreams coming true with Flink and Delta, right? That's awesome. How about you, Scott?
Yeah, two exciting features I'm really looking forward to are both Z-order, which will help you really optimize how you run the optimize command, which is the compaction that solves the small file problem. That's one really exciting feature I'm looking forward to, as well as change data feed, which will actually let you capture row level changes from your Delta table, which is something that a lot of users have been asking for. And that's actually what I'm working on right now. So I hope to release that in the coming months.
That's awesome. There are all smiles on your face, Scott. So excited. Cool. Denny, how about you?
Well, the first, Fabian and Scott already took my two favorite ones, but in addition to that, I did want to call out all these awesome integrations, right? So we recently released the Presto one, we released the Trino one. There's actually an upcoming one with Pulsar, and for me, it's less about the newer features, but just integrating more and more and improving the features we currently have. For example, improving the Presto writer, working with the Trino community with improving their reader reader and writer. So that's what I'm really excited about, just because it's all encompassing, and you can see how Delta Lake is actually working across multiple systems, not just Spark.
That's awesome. Thank you all. This was a wonderful session. We got a lot of insights, and I'm pretty sure there were a lot of people who asked great questions and got amazing insights into our project. It seems like a lot of people asked about Slack channel links, so they feel please welcome all the new integrations or requests from them. So very exciting. So thank you all for joining. Again, reminder, please join us through all various channels. I posted link in the LinkedIn for all different channels that are available for Delta Lake. And then these sessions are live every 2 weeks on Thursdays, 9 a.m. So please look forward to joining us next. Thank you all.
Thanks, Vinny. Bye, everyone.
Bye.
Thanks.
Everyone.
Take care.